Okay, Peter C2 back again for part 4 of 4, HDR and regulations. So wrapping up the regulations pertaining to the use of the HDR applicator. So I've put 35.600 in the title of this presentation. It is not the entirety of the statute. Any section not directly relating to the afterloader or the record keeping, I've left for the reader or the reviewer to sort of explore on their own. So let's finish this up. 35.633, the full calibration measurements on remote afterloader units. It essentially says that every time you replace the source or every quarter, you need to do a full calibration. So the potential sticking point for this, and this is with sources whose half-life exceeds 75 days, is if you're not doing 4 source exchanges on a year, you have to add a full calibration if it happens to be less than 4 source exchanges per year. The output of the calibration needs to be within 5% of the certified value, and the source positioning accuracy needs to be within 1 millimeter, plus or minus a millimeter. For the source retraction with the battery backup, it should happen upon power failure, and you need to check on the length of the source transfer tubes and the timer accuracy and linearity over the typical range of use. The length of the applicators as well as their integrity needs to be checked upon each calibration's time, which hopefully is quarterly, if not quarterly with source exchange, then quarterly without a source exchange. The statute goes on to say that the licensee shall use the dosimetry system described in 35.630, which is the calibrated system to measure the output, and a licensee should make full calibration measurements upon the published protocols of a nationally recognized body. The records need to be kept as 35.2632. Fast forwarding to 2632, then it looks like the records need to be kept for 3 years. So the records of the calibration need to be kept for 3 years, not the records of the calibration equipment, but the records of the calibrations themselves of the sources. The records must include the date and manufacturer, the result, and the results of an assessment of the full calibration, as well as the autoradiograph, and the signature of the authorized medical physicist to perform the full calibration. Just a snapshot of the calibration system. This is an example of the standard imaging HDR 1000 Plus with the CDX 2000B electrometer, a very commonly used system for calibrating the source strength of the HDR Iridium 192. Continuing on. CFR 35.643 periodic spot checks. So before the use of a high dose rate applicator on any given day and after each source installation, there is a spot check of the entire system. This is could be combined with the calibration measurement, but it is in addition to for certain. So the authorized medical physicist should review the results of the spot check, and for this spot check, at minimum, you must assure the proper operation of the electrical interlocks. So for each of the afterloader's entrances, there is a way to disable the source if the door is opened. The interlock needs to be checked. The source exposure indicator light on the afterloader unit, on the control console, and in the facility or in the hallway that's adjacent to that room needs to be checked. The viewing and intercom system needs to be checked to make sure that you can see and hear everything going on in the room. The emergency response equipment needs to be checked for consistency, and it needs to be present. And the radiation monitors used to indicate the source position, including the independent monitor if you happen to have an independent monitor. The timer accuracy needs to be within a second, and the clock, date, and time in the unit's computer needs to be verified. This date and time check is to assure that any decay correction is within a reasonable amount of percent dose delivered. There is no statute or no percentage of time that the computer can be off, although there is a practical limitation that if the clock in the afterloader console and the afterloader itself varies by more than say an hour, then there will be a timer error in its ability to communicate. The decayed source activity in the unit's computer needs to be verified either by physical measurement or by calculation. And the records need to be kept as 35.2643. So 35.2643. The records of this periodic spot check should be kept for 3 years. So it must include the date of the spot check, the manufacturer's name, model, and serial number for the remote afterloader unit source, an assessment of the timer accuracy, notations including the operability of each entrance door, electrical interlock, radiation monitors, source exposure indicator lights, viewing intercom systems, all the safety features, and the name of the individual who performed the spot check, and the signature of the authorized medical physicist who reviewed the record of the spot check. All right, 35.652, radiation surveys. In addition to the survey requirements for 20.1501 of this chapter, the licensee must make sure that their surveys ensure maximum radiation levels and average radiation levels from the surface of the main source safe of the source in the shielded position does not exceed the level stated in the sealed source and device registry. This survey required by the paragraph A above that we just discussed should happen following the repair to the source shielding, or the source driving unit, or other electrical or mechanical components. So the records need to be kept as 35.2652, and that is for the duration of the use of the unit. So for different records, there is different durations. So those records must include the date of the measurements, the manufacturer's name, model, serial number of the treatment unit source and instrument used to measure the radiation levels, and each dose rate measured around the source while the unit is in the off position, and the average of all the measurements, as well as the signature of the person performing the test. CFR 35.657 Computer Systems. For the treatment planning system, for the therapy-related computer systems, there needs to be some checks performed, and there needs to be acceptance testing on the treatment planning system to demonstrate that the published values and published protocols generate consistent results for simple test plans before we go and try and create patient-specific test plans. So the source-specific input parameters required by the dose calculation algorithm need to be verified. The accuracy of dose, dwell, and treatment time calculations at representative points need to be checked. The accuracy of isodose plots and graphic displays need to be checked. And the accuracy of the software used to determine sealed source positions from radiographic images, as well as the accuracy of the electronic transfer of the treatment delivery parameters. So every part of the process that goes from when the physician generates his prescription to the end part of the delivery needs to go through a quality check to assure that it's accurate. So the end-to-end test, as it's sometimes called, is a great check to make sure that we have everything in place as is mandated. So, previously mentioned, for the performance of an HDR procedure, there needs to be an authorized user and an authorized medical physicist, in addition to the radiation safety officer on site being informed of the safety procedures. I'm going to forego the statutes related to that and say that there are 3 important things that need to be completed. For the authorized user physicians, it's 35.690, which is in addition to what you might need for 35.300 or 35.400. 35.51 is training for an authorized medical physicist, and 35.50 is training for a radiation safety officer. So please refer to those statutes for training on authorized personnel. That's going to do it for us today. Thank you for paying attention.